So this is a video about a System 11 speaker upgrade I did recently for my Whirlwind. The parts cost about $65, and I thought that would be of general interest to the community. So System 11 speakers, these are the stock speakers that were in my Whirlwind. There's a 3.5-inch paper dome tweeter, a 6.5-inch paper dome mid-range, and a 6.5-inch paper dome woofer. I put woofer in parentheses because it's the same size as the mid-range, and in fact it's the identical speaker to the mid-range. So this is a kind of a weird choice. I don't know why they put such a big cabinet speaker or such a fairly big speaker in the back box and the same size in the cabinet, but that's what they did. Now I've pulled a lot of speakers out of cars, some speakers out of pinball machines, and they all pretty much look like this. These speakers weren't any good. Their quality was cheap when they were first manufactured, and this is 30 years later. So they certainly haven't gotten better over time. I would call them cheap, and they sound cheap. There's just not a lot of definition or a lot of audio quality there. So what sort of options do we have? Well, by far the simplest, if you want to address this, is to buy one of the commercial replacement kits. Come with all the parts. They're easy. There were a couple reasons they didn't quite do what I wanted in this case, and I'm a little cheap. So I thought I could do it cheaper and it would be a fun project. And that way I get to do it the way I want to do it, rather than the way they decided to do it. Second option is to just look at those specific drivers, the 3.5-inch and the two 6.5-inch, and just replace them with better quality drivers. Nothing wrong with doing this. Installation is easy. You can probably find drivers that fit the existing mounting holes, so that would mean you don't have to modify anything. High quality single drivers are a little bit pricier than some of the other options, simply because they aren't used that much. The market is not that great. If you're going to do this, you need a crossover. So you need to keep the high power bass frequencies away from your tweeter, or you can burn up your tweeter, and you just need it for the optimal sound. This is a little bit of a problem if you're looking to buy off-the-shelf parts. And the problem is that crossovers are designed, first they're designed for a specific set of drivers. So you need the appropriate drivers to work with a specific crossover. And they're designed to work with speakers mounted within a single speaker box. So a woofer, and then above it a mid-range, and above it a tweeter, very typically. They're not really designed for two speakers mounted in a back box and then another speaker mounted underneath a cabinet pointing down. So I may actually not be able to get the adjustment between those two. I'm kind of worried that I won't get enough oomph out of the woofer. So crossovers just really aren't designed for this, or at least not the normal ones. So a third option, which is the option I went through, is to go into the car speaker world and buy a set of 5.25-inch coaxial car speakers, and then a separate 8-inch woofer for the cabinet. Nice part of this is there's a crossover inside the coax speaker, so I don't need a separate crossover. There are lots of inexpensive but high quality choices in car speakers. It's a pretty competitive market, and you can find, pick your price point, and you can probably find something that's okay. And then what I'm going to do is I'm going to use what's called an L pad to balance the sound level. Basically, I'm going to use that to turn down the back box speakers. And that will have the effect of turning up the cabinet speaker for the bass. I need an L pad in this application anyway, because the amp in the back box is looking to drive about 8 ohms. And when I hook up two of these car speakers, they are 4 ohm speakers, but I'm going to hook them up in parallel, so they will only be 2 ohm speakers. And frankly, if I connect them right to the amplifier, I stand a good chance of toasting the amplifier. 8 ohm amps do not like 2 ohm loads. This is by far the hardest installation. So not only do I have to do the L pad and do the wiring separate, I have to change the size of the speaker panel in the back box for both speakers. Now, if you wanted to make this a little bit easier, you could go with 6.5-inch car speakers, and then you'd only have to change one of the spots in the back box. Just make sure you get them thin enough. They have to fit, the rim that the speaker mounts on has to fit underneath the display board a little bit. Kind of see that in later pictures. So, what components did I end up with? So I looked around a bunch. I wanted a speaker that was fairly thin, where the mounting ring was thin. I wanted a coaxial, a decent quality coaxial, and I settled on these Kenwood KFC 1366 5.25-inch speakers. The mid-range, the main cone, is made out of polypropylene, which is a pretty common choice for cars because of moisture. Here it's a nice rigid speaker. The tweeter is made out of a plastic called PEI, which is also a nice choice. So you can expect nice sound from these. They're high efficiency, which means they produce a lot of sound for a given amount of power. That's good because we don't have a lot of power in our amplifier. For the woofer, I chose this woofer, GRS 8PR8, 8-inch woofer. So a size up from the 6.5-inch. It has a polypropylene cone, like the other speakers, which is, I didn't really aim to get that, but it's nice to have a similar cone material. And then finally, I have this L pad attenuator. It's a mono attenuator because there's only mono in system 11 sound, and it can handle 50 watts, which is way more than we need here. All of these came from Parts Express, which is a nice place to buy this sort of stuff. The Kenwoods were $39.99. The base woofer was $13.98, and the L pad attenuator was about $10.50. So I put most of my money towards the 5.25-inch speakers because, frankly, they will have the most effect on the sonic quality. They're the ones that are pointing right at me, and they'll give me most of the sound is coming from them. And if you wanted to, you can find 5.25-inch speakers cheaper than this, and they will still sound better than the stock ones. So I'm going to start by talking about what I did with the cabinet speaker. I actually did the cabinet speaker last, but I think it's a simpler thing to talk about, and so I decided to talk about it first. And here we have the two speakers, the old cheap one on the right and the nice new one on the left. And what I needed was a way to essentially cut a new hole for the speaker. And because I like doing stuff with CAD, I did a little CAD design here. So this looks kind of like a spacer ring. The outer circle isn't really used for this application. You'll see that in a second. But the inner circle is 7 1/8 inches, which is the distance across that speaker. And then the 4 mounting holes are at 7 5/8, which is kind of right in the middle of the mounting holes for that speaker. So I did this. The design was in Fusion 360, which is what I typically use. So I now have this design, and I did a CAD design for a very specific reason. Now, if you were doing this purely with hand tools or hand-guided tools like a jigsaw, you could still use this sort of approach. Take this design and just print it out and use it as a template to draw onto things. That would be a very nice way to improve your quality rather than just sketching by hand, and probably be a little quicker, or at least it would be quicker for me. For me, I actually have a fun tool that can go directly from the CAD. So I'm going to switch over to a video here. Hello, so now we're on to the last part. So I finished the back box, and now we're moving on to the woofer. And all the woofer has is a mounting kind of square of plywood. This mounts to the cab. The speaker mounts to this. So the old speaker was here. This is actually the bottom. and I have it screwed down to my base here so it doesn't move. And up above this, I have some really weird tape on a piece of scrap. And the reason I have that is I'm going to use one of my cool tools, what's called a shaper origin. This is a CNC controlled router and a handheld router. And rather than explain exactly what that means, I'll probably just demo it. So basically I have a little screen here, normal router here, computer with vision system here. So I can do a scan, and basically what I'm doing is I'm scanning over, I'm allowing the router to create a model. So on the screen it's showing me where it's scanning, and I also need to know where the hole for the old router, for the old woofer was. So basically I'm trying to get a position there, then I'm going to come around and do the same thing from the other side. So the camera can see pretty wide. So that's basically just creating the model. Now I can hit finish, and it's taking all the pictures it took and building them into a workspace. And now I essentially have on my screen here, I have a picture that shows that, and then I have a picture down in the bottom that shows the base plate and the hole in it. So, and if I move around, I don't know if you can kind of see it, the router knows where it is. So it kind of changes its position. Now I can import, and I did a design, essentially has the bigger hole that I need to cut for the 8-inch woofer, and then it has 4 mounting holes. So I loaded it. It loaded it over Wi-Fi, kind of from the account that I have for this. I need to rotate it 45 degrees just because I guess I don't really have to. That's where the existing mounts were, mounting holes were. So I'm going to do them at 45. In this case, I could have left them exactly where it was. And I'm just basically going to eyeball the new router hole over the old router hole. I hit place. And now basically I'm in the state that I need. I can flip to cut. And the first thing I need to do, the way this works is the router itself has motors. It has motors to move it up and down, that direction and that direction. So I'm going to roughly follow the circle that I need to cut, and it will move the router to keep it exactly on line. Now it also needs to go to the right depth, and what I can do, it does what's called Z-touch. And there's a bit in the router where it goes down until it touches, and then it can feel the resistance, and then it backs off. So now it knows how deep I need to go. So I think I'm going to do the mounting holes first. This part's going to be a little loud, so I'll essentially drill the 4 mounting holes through, and then I'll come back and just do the main woofer hole. And I'm going to do this, set the depth, and probably can't see it very well here, but right here it shows me I have a mounting hole. So I can just have it, and it'll just go and cut all the way through, just essentially do what I need. So this is going to get loud. Okay, so I've turned the sound way down. I'll probably just mute it here. So basically what we're doing here is it's overlaying that design on top of the workspace that I created. So now I went and I did something here. I just got a software update, so it turned a feature off. So I turn on a feature called Helix, And what it's going to do, it's going to drill the hole. And if you watch closely, it goes down and it just does a helix. The hole I need to drill is a little bigger than the bit. And here I'm adjusting. I thought it was not quite deep enough. So I'm just drilling the same hole a little bit deeper. And so that's the first one. I'm trying to figure out what to do, whether that's going to be deep enough. We'll go over, you might be able to see this one again, but you can see the hole there. Down and watch it spiral around as it cuts. Okay, I'm going to move it off to the left. When this was cutting, it wasn't cutting with a lot of resistance, so I thought it wasn't cutting very much. And I actually didn't know how thick this was. Turns out it's about a half inch, a little bit less. So I went and cut that one, figured half an inch was enough. So spiraling down again. And there you can see the display a little better on this shot. You can see the router actually knows where I want to do this, and you can see it spiral around a little bit. Okay, and that's the 4 holes cut. And that was really pretty simple. Still felt it didn't have enough resistance, so I'm going to grab a little awl here, pointy awl to test the depth. So, and put it against my thumb, put it against the edge, and just verify that yes, they are all the full depth and they do go all the way through. So that's all for cutting the holes. Something else I'll need to do a little bit there. And now I'm going to go and do the main cut. And because this is a small bit, it's only an 1/8 inch bit, the router is not giant. It doesn't have that much power, and I can't really cut a half inch all at once. So I need to do this in several passes, and I'm doing this at 1/10 of an inch, and then 1/20, and so on. So all I have to do is kind of keep you can see there's a little circle on the screen, and there's a dot there that shows me where the bit actually is, or where the cut is supposed to be happening. So all I have to do is keep the circle within that. And if I stray too far out of it, the router will just retract the bit so it doesn't mess up. So now we're going to 2/10, cutting, and I just go around. And if you watch the head of the router, you'll see I'm okay at tracing, but every once in a while you'll see it kind of move to the side. And that's it readjusting so that I'm following the path that I really need to follow rather than the one that I'm drawing. So that's the 3/10. I'm going to do 2/10, that's 3/10 coming up. Then I'll do 4/10, then I'll do 4.5 because I thought that was deep enough. Then I'll do 5. And that part is pretty boring, so we're going to skip ahead a little bit. Okay, now I went back and in the design I did a little bit of countersink so that the screws for this would be countersunk because otherwise they'd interfere with the cabinet. And here's me doing one of the cuts for that. I was able to cut something there, but it turned out they were actually not quite deep enough. So I ended up going back and drilling them out later. And finally, let's skip. And there we are. So it's mostly centered, not perfectly, but certainly good enough for this application. I have holes drilled all the way through. Bolts are going to come through from this side with the speaker on the back. And then I did some countersinks here for the screw heads so they can recess in. This might not be big enough. I might not have quite designed them big enough in the CAD, but I may just have to drill them out a little bit. But that'll be pretty easy. So And there's one modified woofer ring. Really a pretty crappy piece of plywood when you look at it. Hello, so now... Okay, so we got the woofer ring done, and now we need to put the speaker in. So here's the ring as it came out. You can see the nice little countersinks there. And then you put the bolts in, or the screws in, and flip it over, and here's what it looks like. So now we're going to head off to the actual cabinet. This is what my cabinet looked like. I have no idea what happened to this piece of particle board or MDF, but it has like a big problem with it. My guess is they got something damaged. They decided to use it for a bottom, and they figured if the speaker was there, it wouldn't matter. And they're probably right on that. So you can see the outline here. And then I just have a nice picture of the speaker installed here. A couple tips. The first tip is that when they drilled the corners to hold that mounting plate down, they did not drill it with a jig. So you can't rotate it and expect it to fit. So I had the speaker all nicely mounted on there, and then I brought it in, and the orientation was wrong. So I had to essentially mount it in the orientation that worked and pull the speaker out and rotate it around. I found that the connections, the crimp-on spade terminals, worked fine, but they were a little loose. So I kind of crimped them down with a set of pliers before I put them on. And then finally, there's a little ground wire that comes and attaches to the speaker. I probably should have scraped off the speaker. I chose not to. I don't think that ground is a particularly big deal. So anyway, that's the cabinet speaker in. Works fine, looks fine, has a lot of clearance. Will be a big improvement over the existing one. So now we're going to move to the back box. And not surprisingly, the first thing you have to do is you have to take the speaker panel off, disconnect the connectors, and then disconnect. There's a ground wire that comes across that I unscrewed. I actually found out later there's a nice little thumb screw in the back box. You can take the thumb screw off and just disconnect it that way. Then take it, put it on a bench someplace, remove the speakers, obviously, remove the digital display board, remove the light display board, and remove the front plastic. Now on mine, the front plastic just kind of fell off. It wasn't really adhered. It might have some adhesive on it. You might have to carefully pull it off. If you do, be careful that you don't scratch the back. I also took this opportunity once I had it off to clean off the back of the plastic. There's the spots where the bulbs are that were a little bit hazy, a little bit brown. So I cleaned them up with some Novus, and that cleaned them up really nicely. So you might want to do that right when you pull it off. And then we have to deal with the grill. And remember, one of these sides for the speaker, we're going to have to enlarge. And the front is covered by this Williams logo grill. This one actually shows the other side. I took a picture of this because it looks like somebody threw coffee at it or something. But this grill is held on by the 4 little copper-colored staples in the corner that you'll need to remove. I did it by using the putty knife in the upper right corner to kind of get between the grill and the wood and just carefully kind of lift it up a little. And that lifted the staple up enough so I could grab it with some pliers and set it aside. You want to keep it to put the grill back on when you're done. Then when you take it off, you'll see on this side, this is the side that had the tweeter, you'll see that I have a small hole that I need to make bigger, and then I have 4 T-nuts. And the T-nuts need to come out because I'll probably be cutting right across them. when I make this hole bigger. So easy way to do that, just take a screw, put it in from the back side, hang it over the edge, and just tap it with a hammer, and they'll come right out. So that leads us on to some more CAD work. Since I had that whole speaker panel out and with nothing attached to it, I did a full CAD drawing of it. So this is, as far as I can tell, dimensionally accurate. Most of it I did with calipers. It's not perfect, but it's pretty darn close. So if you ever think you might need to recreate one of these, I have a CAD design that you could use to do the recreation. I might possibly be convinced to actually make one for you. Maybe not. But once again, you could print this out, use it as a template for your own, or send out the CAD design to someone else and have somebody else cut it for you. So this is mostly I did it just for fun, but I really didn't need that for this project. What I did need is this speaker adapter ring, and the outer set of holes in this are spaced at, I think, 6 1/8. That's the existing diameter for the 6.5 inch speakers that were in there. So this will be used on the side where the big speaker is. And then the inner holes are the 5 1/4 inch speaker mounting. Now I ended up making 2 of these so that I could use one on each side. I thought it would be nicer if both speakers were the same distance from the grill, and I thought you might be able to see the coax, the small tweeter inside, and it might look weird. I think after building this, I don't think you could tell at all. So I don't think you need one of these on the tweeter side that you're going to enlarge, but you do need it on the other side if you're going down to 5 1/4 inch. That should say CAD design, but the picture's in front of it. Sorry. We'll probably see that a lot. So on the tweeter side, I needed to enlarge the speaker cutout, and I went back with the shaper origin. This is a better picture than what you probably saw in the video. You can see the kind of teal colored, and inside of that, that's the actual line I'm going to be cutting. And then, yeah, that's the actual part I'm going to be cutting, and then it's overlaid on top of the picture it has. So this is what the setup looked like. I have the speaker panel clamped on this side, so it's not going to move. The domino board, that weird tape is called domino tape. The domino board there is clamped down so it doesn't move. So everything is fixed really nicely in place, and that'll give me good dimensional accuracy with this tool. So I went off and cut it, and that was pretty quick. And you can see the ring on the right is pretty much concentric. Maybe a little better than the cabinet one, but about the same. What you'll notice is the holes that I did for the T-nuts are actually far too small. And this is because I didn't think I sized them for the screws, not for the T-nuts. So those I just went back with my drill press and a drill bit and just went and enlarged them. And that was perfectly fine for that. For the T-nuts go on the grill side. And for them, I needed to do something a little different. So I needed a little countersink. And I could have done this with a drill bit. I have some nice flat bits, but I did this with the shaper and some of the onboard software for cutting tools, circles. So see, there's just little circles. They're, I think, 1/10 of an inch deep. I think that's the thickness of the T-nut. And then in the lower left one, you can see I had a little issue there. So did that, mounted the T-nuts in. They just go in and you just kind of hammer them in, and this is the mounting for the one of the speakers. Took that outside, and this got spray painted, so you notice it's a nice matte black all over. I also painted the speaker rings because they might show through on the grill. Once again, I don't know if that's really important, but I had the spray paint and I didn't want to have to go back and redo stuff afterwards. So there it is, and then reinstall the the grill on top. And we're pretty much done with modifications of the speaker panel. So we're now at the point where we want to put the things back together. So here's the panel sitting inside at my desk. You notice the right side is the one that had the big speaker in it. The left is the side that had the small speaker. So, and then you can see the trim rings above. We're going to start with this one, and this is the one that used to be the tweeter. I call it the right speaker because it will be on the right when we install this, working in the back, so it looks like it's on the left. And this is pretty simple. I just put the ring down, flip the speaker over, and screw it in. And I got all that, went together really well, looked great. And then I realized that I had the alignment wrong. I did it this way because the little coaxial speakers on the front say Kenwood across them, and I didn't want that to be sideways. Turns out you can't see it through the grill, and you need the wiring to be towards the center. So got this all set up, thought it was great, and then immediately took it off and rotated it 90 degrees to the left and reinstalled it. So that was the one that was tweeter. Now at this end, we're having to use the adapter to get smaller. So what I did, I put in the screws that are going to go into the existing T-nuts, and then I put the speaker on, and then I bolted the speaker onto this. And then it's merely just a matter of tightening those screws down, and we got both of our speakers put on. And that took about as long as it took me to tell you to do it. It's just like a few minutes. Now, next part, reinstall the parts. So this is the, I guess, light strip. This does the lights across there. This went in great, except for at the upper left, the ring was just a little too big. And this might be a nice reason not to use the ring on that side. I ended up just cutting it back a little bit with that X-Acto knife so that it would fit. Everything else went together fine. As I said, it might be a nice time when you have this off to clean it. This is actually the after picture. I didn't bother putting the before picture. And you can see that this Whirlwind really is a player's machine. It's not a restoration machine. So I cleaned it off and kind of got rid of some of the obvious gunk, but you can see there's still some really unfortunate scratches here. I just don't notice them on this machine. So that goes on, and then you mount the trim piece at the top, the trim piece that the back glass is going to slot into. And a few things to note here. First, if you look on the spacer for the speaker, you'll notice a little chop across the bottom there. It was once again a little too big, and the trim piece ran into it. I had to do that on both sides. Notice I put the brackets back on. The other thing to notice is that there's a ground here. And this ground is the most important ground for this project. And the reason why is this metal trim piece runs across underneath the display board. And the display board has 100 plus volts to drive the display. So if something failed there, you ended up with something weird, you could end up with this piece of trim energized, and that would be bad. Now the way the original installation worked, that little open spade was connected to the speaker, and then there's another spade connected to the speaker that went off and connected into the back box ground. My speakers are painted, so I'm not sure they're good connections for that. So what I did was I just inherently just cut off that one connector and just put in a crimp butt connector. So my ground now just runs to this top trim, because that's really where I thought I needed it. So on to the wiring. Now the first thing to say for the wiring is the wiring actually runs under the display board. So if you put the display board on first before you put the wiring harness back, you'll have to remove or at least loosen the display board to fit it underneath. I missed that, and then I also missed that the screws had the connectors, the little wire holders on them. So the wiring is really pretty straightforward. So in this shot, I have the two speakers wired in parallel using the stock wiring. So there are wires that run from the left speaker down to the right speaker. Now, it doesn't matter which wire you put where. You can choose the yellow one, the black striped yellow to be plus, or you can choose it to be minus. It doesn't matter which you choose, you just need to choose the same thing for both speakers. So if you don't do that, they'll be out of phase, and your sound won't be as good, although you may not notice it. So you do that. Now the L pad has two wires connected to it, and here's a nice little picture of the L pad box that shows you how to connect it. So you notice the amp connects to terminals 1 and terminal 3, and that's where the wiring was in the last picture. And then we're going to connect the speakers to terminal 1 and terminal 2. And that's what we have here. There was a little chunk, short piece of wire that came with the speakers, and I just cut it off and used it here. So we now have the wiring going towards the top, has the connector that'll connect to the amp in the back box. It comes in, connects to 1 and 3 on the L pad, and then the other two, whatever the correct two numbers were, connect off into the speakers. So that's really pretty simple. The wiring's not that hard to do. I do have a problem here, and the problem is, how do I mount the L pad? And this, I think, is one of the things where my solution isn't great. I thought about it after I did this, and I realized that the best thing to do would probably be to mount the L pad in the back box and just cut you have wiring from the amp to the connector that goes to this board, and just cut that, wire in the L pad in line in that, and then like hot glue the L pad to the side of the back box or something like that. I think that would by far be a better installation. Unfortunately, I didn't think about that until afterwards. So here's what I ended up doing. I took this L pad, I took a little spade terminal and opened up the wire end so it was flat, and then hot glued it onto the side of the L pad. And there's one out of focus picture, and here's another out of focus picture, but you can kind of get the idea. And there's a little space between the spade and the L pad, so that's all filled with hot glue to get it in the right place. And then here's an in focus picture that shows you a little better. I just used one of the mounting holes on the display board. And you notice that there's a lot of space between that mounting hole and the traces on the display board. If it had been closer, I wouldn't have done this. But as it is, I don't worry about that electrically, and it's actually a nice solid mounting. And when this is in the final position, you can just easily reach and grab onto the L pad. But as I said, I think you should actually put it in the back box. Do it the right way. So obviously I did that. Then I just took it back, hooked up all the cables, put it in, put it on, and then played around with the L pad until I got the bass and bass mix that I wanted. What I noticed is, not surprisingly, there's better bass. It's a 8-inch woofer and a higher quality 8-inch woofer. I wouldn't be surprised if the 5 1/4-inch speakers actually put out better bass than the old 6 1/2 one did. The big thing I notice is the mid-range and the treble are much, much clearer than they were with the old cheap speakers. So that's the project. That's my $65 Williams System 11 speaker upgrade. Thanks for listening.